we're going to session 3, which is about empowering pediatric brain tumor research through enhancement of multimodal data analysis. Our first speaker does not need an introduction. I always love introducing Adam because you're going first.
So this session actually was a rapid change up because we had the privilege of announcing the Radiant initiative this morning. I just want to call it Erica Kim. I think raise your hand. Erica is our program manager essentially for the Radiant initiative. Thanks so much for joining. I think you'll see there's a lot of excitement on this, and this is going to be a really fun session in part because I think some of the questions that were being asked will be answered. For me, the ARPA-H initiative and what it represents is building on everything we heard today. We always start with this sort of challenge framework, starting with CBTN on the left-hand side of annotated specimens to drive data generation that can become interpretable information, knowledge, and then impact. And this underpins this trilogy of data that almost everybody wants, whether it's a brain tumor community or not. Highly profiled patients and samples linked to mechanisms and their patient outcomes associated with the treatment, intervention, and response. I was trying to think about how to introduce this session and where we're trying to head, under ARPA-H and some of the challenges that I think you're hearing. And there's this meta layer, for me at least, that goes back all the way to the origin, at least even of my career, where, I think, when I first met Jay at Hopkins, this was right after the Human Genome Project had just began. And, for me, the genome suddenly became this highly intimate way of understanding, biology. But what blew my mind was when I stepped into the OR as a graduate student and the intimate framework of a surgeon, right, inside someone's head, right, touching tissue in that context. And connecting between those layers of, for me, again, this notion of connection and intimacy. I know these are sort of weird concepts to think about in a scientific framework. But over and over, for me, this is the challenge of how do we connect the data to the user? How do we connect the data to the patient? How does that patient data become meaningful to that patient? And so it's really that challenge that drove, I think, a lot of the CBTN's architecture. This idea of how do we make science an intimate and connected process. And I think ARPA-H is the next phase of that context. So I just want to make sure we as a community have a shared understanding of at least what we put as the overarching aims, and then I'll hand it over to the rest of the team. So one of the first aims was this notion of local deployment, of architecture. So the CBTN has functioned to some extent by centralizing resources into a data coordinating center. But as much as we try to accelerate that process, there's still a gap in time and implementation, particularly as Vincent highlighted, the opportunity to actually support the interpretation of data in more real time at the institutional interface as a context. So that's one of the first experiments, is how do we bring that architecture that's been supporting large-scale interval-based analysis into the immediate N of one context of patient care, recognizing that that's not what's currently happening at the interface. The second part is really, and you heard a lot about this, and Javad set the bar for how can I just ask this question? Allison hopefully will be able to show you that that's one of the first. It's so clear, right, that Vincent also highlighted this. I think Allison will sort of, we all bear the scars of all of you coming to us saying, which portal again do I use, right, as a context for this. We heard a lot about AI as a tool for interpretation, but an AI is a tool for enablement of just asking questions about data. What's available as a context is a very low bar that we should really try to engage. The third aim is really focused on this clinical data architecture, whether that's social determinants of health or any data that resides at the electronic health record context. Nara is right. It should be easier, right, to do that, but it's not. It's hard, actually, to do it. Luckily for us, we're going to have some key partners in that implementation, and Alison will highlight that as well. And I think the other part, and CBTN always is trying to navigate this context, is to leverage what is an emerging landscape of both technology and policy. So this context of emerging technologies like in tools like FHIR that we've talked a little bit about, these cloud-based environments, artificial intelligence, have to pair with the policy context. And tomorrow morning, you'll have a chance to hear a little bit more about the ONC-based efforts, and you'll hear a little bit about that from some of our partners at Node2. But that's the other, I think, domino that's following is a policy framework for the exchange of data and the standards application, and that's what we're trying to leverage as part of that. So I just wanted to start with that framework of those are the aims. They're trying to address challenges we haven't yet been fully able to address as part of CBTN. And it's going to take really this combination, which is part of the theme that you've heard today at this meeting. Academia can't do it on their own. I don't think industry can do it on its own. We really need this interplay between industry, academia, government entities, and consortia-based efforts. The exciting part, I think, and you've heard threads of this, is that we as a pediatric community are more willing and able, as powered by patients, their families, and their commitment to data sharing, data enablement on behalf of diseases where there isn't a curative framework to drive this new solution space. And so it's within that context that we sort of transformed this session into the ARPA-H session so that we can jointly as a community engage that process. It's going to be an evolving process. I think that's one of the things that's really exciting about ARPA-H, is that, at least as Erica says it, they're willing to iterate, develop, change course as we learn new things in this context. And so I think this is going to be really community-partnered effort that we have to engage, especially when it comes to AI. And I think that's going to be one of the really high points for the rest of the session, is that AI has to be us in some way as we move forward. And with that, I'll turn it over to John.
And thank you very much for setting the stage. It's an honor to have Dr. Rod Tarrago from AWS, who will give us an introduction to generative AI.
So I have the privilege of having been at AWS for 3 years now. And before this, I was at Seattle Children's Hospital, where indeed we did implement Epic. And Sarah's right. I mean, a lot of it is cookie cutter. A lot of it is out of the box. You're given this thing. And unfortunately, it isn't always the clinicians who are deciding. But in preparation for this, I was flying a few weeks ago, and I got to watch First Man. And I don't know how many people have seen this movie with Ryan Gosling. And Ryan Gosling does a really good job of depicting Neil Armstrong. What I didn't realize, if you watch the movie, is that Neil Armstrong's daughter, Karen, died of DIPG. And this is in the early 60s. And the stories that you have told dwarf what comes across in the movie. But it does a good job of it. But what was interesting to me is additional preparation for this. I looked it up and I read this, which is the therapy since Neil Armstrong's daughter hasn't changed much for this disease process. And so that's why you're all here, why we're all here. And a lot of it, as we've said, comes down to data. And data is an interesting thing because there can be too little data or it can be too much data. So I'm going to pick on Sarah, actually. So Sarah, they've done a study. Mayo did a study. And I was a pediatric critical care physician, so I'm curious if you know, on average, how much data does the average critical care physician, how many data points does each critical care physician deal with in a day, in one day? How many data points? Or if anybody else wants to take a guess, how many data points does the average critical care physician see in a day? That they see, that they're exposed to. Pay attention, that's the next slide. I've heard 5,000. Close. It's not like The Price is Right where you can say one. It is 50,000. 50,000 data points in one day. You're seeing continuous data, you're seeing discrete data, you're seeing imaging data. You're seeing all the notes from all the consultants coming in that have data within them. So it's a lot. And so when they talked to clinicians, they actually don't want more data. They want better data. And so that's our challenge, is how do we get better data? For the first time, I think, in a long time, we have a tool that I think gives us some hope. For my 20 years in informatics and in healthcare tech, the mantra has always been, I don't care what you do with your technology, I don't care what it has to fit into my workflow. Never mind that the workflows we all follow are 1970s paper-based inefficient workflows that have been made electronic, but that's what we've had to fit it into. Generative AI is potentially allowing us to say, let's blow up that workflow. Let's potentially allow all 30-some sites to document things differently, because maybe the tool will help us with that. It's early on. This article is November 2023. It seems like 10 years ago that generative AI and ChatGPT and everything came out, but it hasn't been that long, but it has evolved so quickly. But it is truly transforming how we do things. And I'm excited to have Allison show this. But it is going to take some work. How many people are old enough to know what this is? How many people still have cassettes and CDs and things? I mean, we still have them, but they're collector's items now. When this first came out, and I remember I was in college, it was thought to be the death knell in the music industry. Music was going to die. Artists were going to starve. Nobody was going to make music anymore. But it didn't. It's all of a sudden now you can get one song instead of 10. If you don't like the other 9, it doesn't matter, because this allows us to do that. And so for the first time now in healthcare, we're going to be exposed to a tool that makes us completely rethink how we use data, how we govern access to data, how we request data. One of our really smart solutions architects at AWS built a chatbot that, like what Allison's going to show, allowed us to query data. And this goes to Adam's point about how we all have to work together. And he built this chatbot and he said, watch this is really cool. Ask it a question. And so in the demo, he said, how many patients in this cohort have diabetes? And he said that there are 1,100 patients with diabetes. And then he went on to the next question and said, well, how many of them are female? And I raised my hand and said, wait a minute, what do you mean by diabetes? And what do you mean diabetes? Diabetes is diabetes. No, it's not. And so where we're not yet is where we have a thing that's a tool that says, well, you asked me what diabetes meant, but did you mean diabetes mellitus or did you mean diabetes insipidus? If you meant diabetes mellitus, did you mean type 1 or type 2? And if you meant type 1, was it adult onset, or, all of these different questions that right now that they're just too dumb to ask us those questions, but it's not far till we get to those things. So we need a strategy. We need an AI strategy. We need a data strategy. And when we go across academic medical centers, we sort of see a couple of different flavors of this. We see people who say, from the CEO down, we need to do generative AI. Why? Because everybody else is doing it. That's not really a strategy. It's because everybody else is doing it. And at the same time, there are some who are embracing it, and some who say, no, it's still dangerous, so we can't use it. And the truth is probably somewhere in the middle, but we do need a strategy. I use this quote in every single presentation I do, and I always ascribe it to the author. So Bimal Desai, CHIO at CHOP, said this about 2 years ago. And I don't know why there's a picture down there in the lower right. Somebody took a screenshot. But it says, automate the boring, let humans do the rest. That's where we are today. Today in October of 24 with generative AI in healthcare, automate the boring and let humans do the rest. And when you think about some of the efforts that we're putting into with CV10, it kind of is automating the boring. And so what does that mean? When it comes to registries, collaboratives, research collaboratives, this is not an overestimate. It is literally billions of dollars across healthcare that we're spending on inefficient work. Johns Hopkins published this about a year and a half ago, where they looked at not even specialty collaboratives or specialty registries. They looked at the ones that every hospital does, Joint Commission, US News, Leapfrog, CMS, those things that kind of everybody has to do. And they looked at the resources that they, one hospital, are putting into the data entry, as Adam mentioned, the manual data entry for these registries. Take a guess. How much money and how much time is Johns Hopkins spending on just those 5 registries? $108,000 and $5.6 million in data entry. Not to mention the time it took to get those things in and the time it took to insights. So this is clearly an opportunity. We're working with one of the other registries that is pretty widely used called NSQIP. NSQIP is a National Surgical Quality Improvement Program. It is a program that a lot of hospitals, adult and pediatrics, use to benchmark their performance. We looked at this for 2021. If it takes about an hour per patient to enter data, we figured out that for NSQIP in 2021, the United States spent 113 human years on data entry. It's not okay. That's why we're all here. We're here to figure out how do we improve the boring stuff. And so, and what we're working on right now is even if all 3 or 5 or 32 or 35 sites are entering tumor staging a little bit differently, let's at least today just map it out. Map it out once so that going forward, every time you have a new patient that uses that field, it's automated. It's not rocket science, that part. There are other things down the road that are going to be rocket science, but for now, let's automate the boring. When we look at generative AI, we can't ignore the potential bad things that can happen with it. And so we have to safeguard against those. The really cool thing is that I saw this quote the other day, and it's true. The AI, how many people have used a generative AI tool, ChatGPT, Claude, whatever? The tool that, and who's used it today? So the really cool thing is that the AI that you use today is the worst AI you will ever use, because it'll be better tomorrow. And it's going that fast. So when you see the ratings of this is the best large language model, just give it a day and it won't be anymore. So here's proof. Claude a few weeks ago was known as the best large language model. I think it might have been supplanted by GPT-4o or Open or whatever. But anyways, I asked it who I was. Who is Rod Tarrago, MD? It completely made this up. I am a Filipino-American born physician who likes to peddle alternative medicine theories, including metabolic toxemia of the insane and just wait and see. I Googled this. This person does not exist. The large language model made it up on its own.
Make me an MD. So
Yeah, exactly. The cool thing is that I looked at this a week after this and it was gone. It said, I actually don't know who that is, which I don't know if that's good or not, but at least it didn't make things up. Canadian Airlines. What's that? Yeah, this was not the pro. They was like, if you pay us, we'll give you the real stuff. Yes.
do it.
So Canadian Airlines had to pay out all kinds of money because the chatbot offered discounts that didn't exist. They went onto their website and they asked things and they said, yeah, 25% off today. They had to honor those discounts, which is kind of funny, and not so much for the airline, but imagine if the same chatbot said, yeah, cut your chemo by 25%. That's the right thing to do. That's not okay. So we have to figure out how to do this. At the same time, we can't be afraid to use these tools. How many people have seen articles, news stories about Tesla or other self-driving cars crashing? We've all seen them. And everybody sees them and says, yeah, we are not ready for self-driving cars. That's proof, right? Proof that we're not ready for self-driving cars. How many car crashes in the United States last year were due to humans texting? 1.6 million car crashes due to us fallible humans doing something we shouldn't have been doing. which dwarfs the number of self-driving incidents that may have happened. So I think we have to keep this in mind as we balance how we approach generative AI. These are sort of the mantras of responsible AI. And I think we have to go into it with these things in mind. And while we won't say move forward and break things, I do think that when we compare the potential use of generative AI, we can't compare it with perfect because we're not. We have to compare it with the current state. I often quote that if pretty much all of us are adults here, if all of us are hospitalized tomorrow, what's the risk of us having an adverse event while we're in the hospital? How many of us? Because there's actually data on this. It's 1/4 of us. So 1/4 of us, if we go into the hospital, will suffer an adverse event. That's what we should be comparing AI to. So if today, by automating the boring, we can just make things better and make things better and make things better, we will eventually get to where we want to do. But I agree with Adam. It's not going to be tech that solves this. It's not going to be individual organizations who solve this. It's not going to be patient advocacy organizations who solve this. It's going to be all of us doing it together. So with that, I'm going to hand this off and excited to hear Allison talk.
Rod, this all is great. Why is the registry work so hard to push through? Why is the work that we're doing with the most forward-leaning, consortium that has data-driven people for discovery, why is it hard? Why is it hard? Why does it take time? Why can't we move faster?
I think everybody's busy. Everybody says they're busy. Everybody's got other things to do. And a lot of people are working with the sort of traditional ways of doing things. We are not by any means lacking advocacy or lacking champions. And it's kind of cool because what we're hoping to do is attack it from both sides. Is not only how do we allow an organization like CBTN to more easily store, more easily analyze, more easily ingest data. What we also have to do is go to the individual organizations and say, how do we make the process of data mapping, data upload, data rationalization not a 9-month, $250,000 project? That's what we also have. That's the next step.
Thank you very much.